High-performance communications satellites are equipped with large parabolic antennas. This is because large-diameter parabolic antennas are required to achieve high gain and wide bandwidth. However, launching a communications satellite equipped with a large parabolic antenna is very expensive. Because satellites are designed to be robust enough to withstand the vibrations of launch, the antennas must be overbuilt, adding additional weight and cost. Therefore, Mitsubishi Electric has developed a technology to manufacture a parabolic antenna on a satellite using a 3D printer in space after launch. The 3D printer extrudes a liquid resin that hardens into a rigid solid when exposed to solar ultraviolet rays. Using this technology, it is possible to manufacture a parabolic antenna that is both larger and lighter than a conventional antenna. Laboratory testing confirms that the concept is feasible by repeatedly printing functional parabolic antenna dishes from UV-hardened liquid resin. Mitsubishi Electric received a patent for this 3D printing technology and a second patent for the development of a resin that can be cured by the sun's ultraviolet rays, even in vacuum. The use of sunlight as a light source for curing the resin reduces the power consumption required to manufacture these antennas in space. To prove the quality of the antenna, we printed a prototype parabolic antenna with a diameter of 165 millimeters and confirmed a gain of 23.5 dB at 13.5 GHz in the Ku band. This technology gives small, cheap satellites some of the capabilities of large, expensive satellites and paves the way to 3D printing very large structures in space. Mitsubishi Electric will continue to conduct research and development toward a better future.